Okay, this is the test review for Unit 2. The first question says, give two specific characteristics of the equation of a linear function. So, characteristics of the equation of a linear function. Well, you should know that the equation of a linear function is y equals mx plus b. You know that m is the slope and the b is the y-intercept. So those would be your two characteristics. M is slope and b is the y-intercept. Okay, the next one asks, give the most important requirement of the equation of an absolute value function. So the most important requirement is going to be, we're going to write the parent function up here for you. F of x equals the absolute value of x. So the most important piece is that the x is inside the absolute value sign. Okay, so you have the absolute value sign, the x needs to be on the inside in order for it to be an absolute value function. So again, the x has to be on the inside of the absolute value symbol. Okay, the next one says, indicate whether each of the following equations and graphs are linear or absolute value. Okay, so we're going to put a circle around linear, and I'm going to put a box around absolute value. All right, so the first one, I see that the x is squared, so I know that this is a quadratic. If you're not sure, you can always put these in the calculator. I'm not going to do all of them in the calculator, but you can put them in the y equals function of your calculator. Let's look at the next one. Okay, I see that I just have the x, and it's not squared, it's not an absolute value, so this is a linear function. I'm going to put a circle around that. Okay, now this is trying to trick you. This looks like an absolute value function. Okay, but I want you to put this in the calculator just to see. So I'm going to go into y equals, and I'm going to put 3x plus the absolute value, you go to math and over to num, press enter, of -7. Arrow out, to zoom 6, so I have the proper viewing window, and you see that is not an absolute value, that is actually a linear function. I'm going to circle that. So again, if you're unsure, please make sure that you plug it into the calculator. All right, this one here is rational. The instructions tell you to write other, so this would be other, but I want you to make sure you're still getting used to knowing all the function families. So these are other. All right, the next one, notice that the x is on the inside of the absolute value symbols, so we can say that this one is absolute value. And when you put that in the calculator, it should look like a V to be sure that it's absolute value. Box around that guy. Okay, this guy's linear. Okay, this one right here. Notice the x is on the inside, so this is absolute value. This one right here is also absolute value. Again, if you're unsure on any of these, put them into the calculator. So let's do this one right here. 2 minus 5, absolute value of -2 minus x. Arrow out. Now notice that this 8 is on the other side. In order for put this into the calculator, you're actually going to have to plus 8 on both sides. So we're going to actually make that 10. I'm going to graph that. You see that that is the absolute value. So any ones that are not already f of x equals or y equals, you will have to solve so that all the information is on one side of the equation. Okay, moving on. See, this is a line, so this is linear. This is also linear. Okay. This is not a V, and this is not a line, so no, this is not linear. However, you can't tell what function it is, so we're just going to put other. And then the last one is a V. It's a very wide V, but it is a V, so it is the absolute value. Put a box around that one. Okay, so all you're doing is recognizing that the equation and then the graph for linear and for absolute value. Okay, next section, moving down, says explain how each of the following parts affects the parent graph. Okay, so remember that each of these things, okay, are different pieces, and something different happens to the graph for each of these pieces. All right, so let's take a look. So it says positive A, okay? Positive A means that there will be a stretch or compression, okay? Positive A. So it will be a stretch. So if A is greater than 0, you have a stretch. If A is between 0 and 1, then you have a compression. Okay. For a positive H, it means it's going to go left H units. For K, plus K is going to go up K units. A negative A is going to be a flip over the x-axis. Minus H is going to be right H units. Can't use that pen anymore. And then minus K is going to be down K units. Okay. And then explain how to find the vertex of the formula above. Okay, so find the vertex for the absolute value. You're going to look at this piece here. We know that that H means left or right. Okay, so H is going to be the x value of the vertex. Remember, the vertex is going to be a coordinate, so I have x and y. So remember that a positive H, because of insider's lie, moves to the left, which means that I'm going to have a negative value for my vertex. And then minus H, which is a move to the right, because of insider's lie, that means that it's going to be a positive x value. And then for my y value, when the K is positive, I'm moving up, so that's just going to give me a positive y coordinate. And then negative K, which is a move down, which is going to give me my negative y coordinate. Okay, so the tricky part here is just knowing that insider's lie for the H, which is my x value. So that's the only two things that you look at when you're looking at the vertex. All right, next one. What is the equation of the parent function of the equation 3y equals negative 4x plus 11? So the trick here is recognizing that this is a linear function. If you can recognize it's a linear function, then you know that the parent function is f of x equals x. Over here, what is the equation of the parent function of the equation f of x equals negative 3 times the absolute value of x minus 2 plus 10. You should see that absolute value, that's your Q, and f of x equals the absolute value of x is my parent function. Okay. Moving on to the second page. Okay, consider the following transformation of the parent function f of x equals the absolute value of x. Draw the parent function, the transformed function, and write the equation of the transformed function. Okay, so my suggestion is that you check all of this on the calculator. So absolute value of x is my parent function. So I know that I'm going to start at 0, 0, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1. But if you forget on the test, get your calculator out and put into your calculator, clear what's in there. You're going to do math over to num, absolute value of x, and hit graph. And it shows you. And if you go to the table, it shows you the values. So you can plot some points. Okay. All right. So now it says we're going to draw the transform function. So I have reflection over the x-axis, which I know means a flip down. So I know that this graph is going to be pointed down. It says a vertical compression of a factor 2 to 3. For lack of a better term, that's your slope. Notice over here we did up 1 over 1, up 1 over 1, up 1 over 1. Okay, because this is rise over run, again for lack of a better term here, because it's not really the slope, but that's how it's that's how you're able to sketch it out for absolute value functions. So up 2 over 3, up 2 over 3, and then a shift up 3 units and then right 2 units. Now the tricky part is you're gonna have to do these first so you know where your vertex is before you can do the other ones. Okay. All right. So I know that I'm starting at the origin because that's where my parent function starts, and I'm going to shift up 3, 1, 2, 3, and I'm going to go to the right 2, 1, 2. Okay. So that's my new vertex. That's my new vertex. So now I know that I'm flipping down, so I'm going to go down. So instead of up 2 over 3, because I'm going down, I need to go down 2 over 1, 2, 3. Down 2 over 1, 2, 3, because of that reflection over the x-axis. Okay. Now, you can't put this into the calculator until you write out your equation. So notice that the vertex here is going to be 2, 3. Okay, I'm reflecting over the x-axis. So what you want to think about is you want to think about what we talked about on this page right here. Okay, and where is all these transformations fitting into this formula? So we know if it's f of x equals, I know that it's negative and it's vertically compressed, so that's going to go on the outside of my equation. Then I have the absolute value of x. All right, now remember that on the vertex, my h value is going to tell me what happens to x, whether I'm moving left or right. Therefore, this is positive, on the inside is negative because of insiders lie. And then I went up 3, so on the outside I have plus 3. If this comes directly from this discussion that we had right here. Okay. Now, you could put that into the calculator. Check just to make sure that you've done it correctly. Remember to get the fraction. I'm going to put the negative in first, but once you get the fraction, you're going to do alpha y equals, press enter. Then I have 2/3 over, and then I need to do my absolute value. X minus 2. Arrow out, plus 3. Graph. Oh, that looks about right. But remember, unless you have that equation right, you're not going to be able to put that into the calculator. Okay, let's look at the next one. Considering the following parent function, f of x equals the absolute value of x. For each of the equations of the transform function below, draw the transform function image. Okay, so this is, again, you could plug these into the calculator, you could do these by hand. I'll do 2 of them by hand and then the last one in the calculator. So I know that I don't have a flip or a vertical compression or stretch, but on the inside here, I know that this is -3, okay, which means I'm moving to the right 3, 1, 2, 3, and then I'm moving up 1. So then up 1 over 1, up 1 over 1. And there is your sketch view graph. Okay, next one. All right, so here I see that you've got to look at each of these pieces. I see here that I have that negative, so it's going to flip over the x-axis. I have 2, okay, so 2 over 1, so I'm going to go up 2 over 1, so that's a vertical stretch. I have +4, and then on the outside the -3. So I know that just from looking at this that my vertex is going to be at -4, -3 because of insider's lie. So I'm going to go ahead and do that. That -4 and then -3. Okay, and I'm going to be going down because it reflected over the x-axis. So I'm going to go down 2 over 1. Down 2 over 1. So there's your sketch there. Again, you can put any of these into the calculator and check. So let's do the last one with the calculator so you can get the practice. Okay, I'm going to put this into the calculator. Alpha y equals gives me the fraction 1/3, arrow over, absolute value, x plus 1, graph. Okay, I see I have a vertical compression, and then I know that my vertex, because this is +1, it moves to the left 1. If you wanted some points to graph, use the ones that are not fractions. So -1, 0. Let's go up a little more here. I've got -4, 1. Let's go the other way and get one more point. 2, 1. And there's my sketch. All right. All right, the next one says draw a graph of an absolute value function that has a domain of -infinity to +infinity and a range of -infinity to 4. Write the equation of your function in your graph. And then what's the vertex? Okay. Well, we know that absolute value functions have a domain always of -infinity to +infinity. So here's the trick here. The range is from -infinity, so it's starting down, and then it's stopping at 4. So if you just compare these pictures up here, okay, if you compare these pictures up here, notice this is pointing up, so it's going to +infinity. This one's up, so it's going to +infinity. If I want the range to be -infinity, that means that it has to reflect over the x-axis. So I know that I'm going up and I'm stopping at +4. Okay, it doesn't tell me anything about a stretch, doesn't tell me anything about a shift or left or right. So I'm going to go down 1 over 1, down 1 over 1 on both sides. So this has a range of -infinity to +4, stops there at +4. So the equation of this graph is f of x equals the absolute value of x plus 4, because I moved up 4. Again, there's nothing about vertical stretches or compressions or shift left or right. Now, we do need to reflect in the equation that we flipped down or reflected over the x-axis, which is going to give me that negative in front. All right, and again, you can put that in your calculator to double check. And then finally the vertex, so we know the vertex is at 0, 4. All right, next piece, graph the following inequalities. Again, you can put these into the calculator. The trick is, though, they have to be y equals, well, It needs to be y and all the variables on the other side. Y needs to be isolated by itself. So let's go ahead and do that first. We're going to do minus 4 minus 4. So that's going to give me negative 2y is greater than 3x minus 4. Okay, I'm going to divide by negative 2. Now remember, when you divide by a negative, that's going to give you y, and you're going to have to flip the direction of the inequality, is less than negative 3 over 2x. Negative 4 divided by negative 2 is positive 2. Okay, so we're going to graph that line. So when you graph the line, I want you to graph it like you normally would, and then you just have to worry about this piece right here, the shading piece. So I have plus 2, so that's my y-intercept. And I'm going down 3, 1, 2, 3 over 1, 2. Okay, so the trick here is the symbols. So I know that this symbol here means less than, so I'm going to shade down. Okay, and it's a dotted line because it's not equal to, so this is a dotted line. Okay, so the first thing I'm going to do is my dotted line, and it's less than, so I'm shading over here. All right, let's look at the next one. I don't need to solve for y, so I'm going to go ahead and graph this. This one I'll graph in the calculator, actually. No, we'll do the last one in the calculator. So this is my vertex here is at negative 1, negative 3. So negative 1, negative 3, 1, 2, 3. There's no stretch or compression, and there's no reflection over the x-axis. So I'm going to go up 1 over 1, up 1 over 1. Now, what you want to be careful of, though, is don't sketch that in until you read the symbol here. So I have the greater than or equal to, which means shade up, and greater than means, and then the equal to, we're going to have a solid line. Okay, so I'm going to go ahead and sketch that in. Solid line. And then we're shading up. Okay. All right, the last one. If you want to graph this in the calculator, you need to graph it like it's an equality. So you don't want to change anything over here. The shading you're going to have to do by yourself. So let's go ahead and put this in. So negative 3 absolute value of x minus 3, arrow out. All right, so I've got my graph. That's what my graph looks like. If you wanted some points, okay, let's go up here. Remember, you want to choose points to plot that are in your graph. So I've got 3, 0. And let's see, 2, negative 3. And then 4, negative 3. Okay, let's look at our symbol here. I have a symbol that's greater than or equal to, which we already talked about, so greater than or equal to. So I have a solid line. And then greater than is going to be out here. All right, the symbols that we didn't go over, just so you can review them. We have the greater than sign, which is going to be shade up with a dotted line. And then the last one is less than or equal to, which is shade down with a solid line. You need to know all of those. Okay, that's it for this video.